Hello everyone, welcome back to Learn Smart with Sweta. In today's video, we will solve all the numericals from exercise 2C of Concise Physics Class 10. If you have already watched my exercise 2A and 2B solution videos, this will complete the entire set of numericals from this chapter. Most of the questions in exercise 2C are based on a single very important concept, the conversion of energy, that is potential energy changing into kinetic energy and kinetic energy changing into potential energy. Once you understand what the question is asking and apply the concept correctly, you will find these numericals surprisingly easy. So let's begin. So let's look at question number 1. A ball of mass 0.20 kg is thrown vertically upward with an initial velocity of 20 meters per second. So there is a ball. Mass of the ball is how much? 0.20 kg. And initial velocity is 20 meters per second. So we can write U is equal to 20 meters per second. They are asking, calculate the maximum potential energy it gains as it goes up. So we have to calculate the potential energy. But we know only mass and velocity. So we will first calculate the kinetic energy. And kinetic energy will be half mv square, which is 1 by 2 into 0.20 into 20 into 20. So we are getting 40 joules, which means the kinetic energy is 40 joules. But they did not ask us kinetic energy. They asked the maximum potential energy it gains as it goes up. So from the law of conservation of energy, this same kinetic energy will become converted to potential energy. And therefore, the potential energy will be equal to 40 joules. Right? Let's see the next question. Now, question number 2. It says, a stone of mass 500 gram is thrown vertically upward with a velocity of 15 meter per second. Calculate the potential energy at the greatest height. So we know that potential energy is equal to mgh and mass is 500 gram. We will convert it to SI unit always, 500 upon 1000. So we have converted it to kg. Now we have to calculate the potential energy at the greatest height. So potential energy is this into g. G acceleration due to gravity, we will take it as 10. And height we don't know, this is what we have to calculate. So what do we do? So you see that they have given you the velocity. We will calculate kinetic energy. So kinetic energy is equal to half mv square, which is half into mass will be 500 gram converted to kg upon 1000 and velocity they have given 15. So we will write 15 into 15. Just calculate. So if you just calculate the kinetic energy, you will get 56.25 joules. But the question was, calculate the potential energy at the greatest height. So same will be the potential energy, because from the law of conservation of energy, whatever the kinetic energy the ball has, that energy does not get wasted anywhere. It only transforms from one form to the other. So the potential energy will be 56.25 joules and this will be, we will write this is 56.25 joules. Then they had asked kinetic energy on reaching the ground. So we are throwing the ball upward and we calculated the kinetic energy of the ball is 56.25 joules. When it reaches the maximum height, the energy will not get wasted anywhere. So that same energy will convert to potential energy. So potential energy will be 56.25 joules. And now the kinetic energy on reaching the ground, when it reaches the ground, again energy will be same. So that kinetic energy will again be 56.25 joules. And the total energy at its halfway point, same. When the ball is halfway, this is halfway, it will have kinetic energy, it will have potential energy both. But the sum of both the energies will again be same and therefore that energy will be 56.25 joules. So remember how the energy changes from one form to the other, and based on that the total energy will remain same. So whatever is the kinetic energy with which we are throwing the ball, initial energy, that same will be the potential energy when it reaches the top, and that same when the ball falls and reaches the ground. Just before reaching the ground the energy will be same, which is 56.25 joules, and total energy at its halfway point will again be same, right? Let's see the next question. Question number 3 is, a metal ball of mass 2 kg is allowed to fall freely from rest from a height of 5 meter above the ground. G, they have told to use, calculate the potential energy possessed by the ball when it is initially at rest. So potential energy equals to mgh. Mass is given 2 kg, 2. G, they have told to use 10, we will take 10. And height they have given, it is falling from a height, it is at a rest height of 5 meters, so into 5. We will get 5 into 2, 10, and 10 into 10, 100 joules. Now, the potential, the kinetic energy of the ball just before it hits the ground. So same, so kinetic energy will remain same before it hits the ground, 100 joules. And what happens to the mechanical energy after the ball hits the ground and comes to rest? Now the ball falls on the ground, comes to rest. What is the mechanical energy? So mechanical energy will be that same 100 joules, but what happens to that? So it will become converted into heat and sound energy, because when the ball will fall on the ground, some heat will be produced and sound will be produced, so it becomes converted to that. So answer will be, it becomes converted to heat and sound, right? Let's see the next question. Question 4. A person swings on a rope from a cliff that is 20 meter high. How fast is the person moving at the lowest point of the swing? You always have to see that what you can calculate. They have given you the height, so you can calculate potential energy. Calculate the potential energy first. Potential energy is equal to m into g into h. M they have not given, we will keep it as m. G they have told 10, we will write 10. And h is 20 meters, so this much joules. Now this same energy, how fast is the person moving at the lowest point? This same energy will convert to kinetic energy. So kinetic energy is equal to half mv square, and this same is equal to this. So we will equate. We will write half mv square equals to m into 10 into 20. Now only calculate. M and m will cancel, and we will write v square. So v square is 10 into 20 into 2. 10 into 20 into 2, which will come as 400. And v will become root 400, which is 20 meters per second. So every time we are using whatever they have given, if here they had given the height, so we calculated potential energy, and same will become converted to kinetic energy. We equate and we get the velocity, right? Next question. Let's look at question number 5. Diagram given alongside this, the diagram shows a ski jump. A skier weighing 60 kgf stands at the stands at A at the top of ski jump. So here he is standing and takes off for his jump at B. So he has to jump here. From here to here he has to go. Calculate the change in the gravitational potential energy of the skier between A and B. So what is the change in the potential energy they have told to calculate? So here he is at a height of 75 meter, and here he is at a height of 15 meter. So what is the change in potential energy? So change is mgh2 minus mgh1. That is the change in the gravitational potential energy. So it will be mg, we will take common, and h1 minus h2. Let me write this h1, h2, which is 75 minus 15, which is mass, it was 60 kgf. So 60 into gravity 10 they have told to take, and 60 into 10 into 75 minus 15 is 60. So this much is the change in the gravitational potential energy between A and B, and we should calculate that. It will come 36 So it will come 36,000 joules. So the change will be 36,000 joules. Next is, if 75% of the energy in part A becomes kinetic energy at B, calculate the speed at which the skier arrives at B. So here the energy was mg, h was 75, so mg into 75, and here the energy is mg into 15, and difference of energy we calculated is coming 36,000 joules. But all this energy is not converted to the kinetic energy. He is jumping, so if only 75% is converted. So we will calculate 75% of this. So 75% of 36,000 is 75 upon 100 into 36,000. You will get 27,000 joules. So only this much is converted to kinetic energy. Now kinetic energy is half mv square, which is half into mass was 60 and we have to calculate. So half mv square, and this is equal to 27,000. So we will equate and get v. So we will write this equals to 27,000. Just calculate. 230 times 3 9s are 27, 900. So v square equals to 900. So v equals to root 900, which will come 30 meters per second. So the speed at which the skier arrives will be 30 meters per second. Let's see the next question. Let's look at this question, question number 6. A hydroelectric power station takes its water from a lake whose water level is at a height of 50 meters. This question actually says that the height is 50 meters above the turbine. So what is the potential energy of the water? mgh. Mass is m, g is 10 and height is 50 meters. So 50, this much joules is the potential energy. This energy converts to kinetic energy, but only 40% of it converts. So kinetic energy is how much? 40 upon 100, 40%. So 40% of m into 10 into 50. Calculate this. 200 m joules, 200 m. Now we have to calculate the power. Power is given 1 megawatt. We have to calculate the mass of water. So first of all, we know that power equals to work done upon time taken. And power they have given, it produces 1 megawatt power. You have to know that 1 megawatt is equal to 10 to the power 6 watt. So we will write 10 to the power 6, or we can only write 1000 into 1000. So this much power. And the energy, kinetic energy, that is only the work done. So 200 m, and time they have told each second. So time we will take 1 second. Now from this just calculate m. So m will be what? 1000 into 1000 upon 200. So the mass of water, you will get it as 5000 kg, and this is how you can calculate, right? Let's see the next question. It says the bob of a simple pendulum is imparted a velocity of 5 meters per second when it is at its mean position. So we can calculate the kinetic energy. So kinetic energy will be how much? Half mv square, which is half into, mass is not given, so we will take it as m, and velocity 5 meters per second, so into 5 into 5. So we will get 25 m upon 2. This is the kinetic energy. Now, to what maximum vertical height will it rise on reaching its extreme position? 60% of the energy is lost in overcoming the friction. Now this pendulum, when it was at the mean position, its energy is that much. It is going from here to the extreme position. Its 60% energy is lost, which means only 40% with the 40% energy goes to this height. So we will calculate the energy which is equal to 40%. So we will calculate 40% of 25 m by 2, which will come as 40 upon 100 into 25 m upon 2. Now just calculate 25 4 times, 4 10 times and 2 5 times. So we are getting 5 m joules. Only this energy, with this energy, the potential energy we have to calculate. So what maximum vertical height will it reach? Now potential energy is equal to that. So we know that potential energy is equal to mgh, and that is our potential energy because only that much gets converted. So which means 5m equals to mgh. M and m we will cancel. G we will take as 10. So 5 is equal to 10 into h. So h is equal to how much? 5 upon 10. Which will come as 0.5 meter. So this will be the height that the pendulum, the bob of the pendulum will reach the extreme position. So this height will be 5 meter, right? Let's see the next question. 0.5 meter. So question number 8, this figure is given. Figure alongside shows a simple pendulum of mass 200 gram. So mass is 200 gram. Now it is displaced from main position A to extreme position B. From A, so this is actually B and this is C. So pendulum goes from A to B and height of B you can see is 5 meter. What is the potential energy of the pendulum at position B? Here we can see at B the height is 5 meter. So potential energy will be mgh. Mass is 1 by 5 kg. G is 10 and height is 5 meter. So the potential energy is how much? 10 joules, right? Now what is the total mechanical energy at point C? Total energy will always remain same. So total mechanical energy at point C will also be 10 joules. And what is the speed of the bob at position A? When it comes to A, what is the speed? So speed, that is kinetic energy. Kinetic energy will also be 10 joules. But we have to calculate the speed. So which means half mv square equals to 10. And we have to calculate v square. So v square is equal to 10 into 2 upon m, which is 10 into 2 upon mass was 200 grams. So I will keep 200 over here and into 1000 to convert it to kg and just calculate now. So it is coming 100. V square is coming 100, which means v equals to root 100 and v is equals to 10 meters per second. So this is how we can calculate the velocity at A. When the bob reaches the point A, we can calculate the velocity. That's it for exercise 2C. I hope these solutions have made the concepts and numericals much easier for you. If you found this video helpful, do watch my exercise 2A and 2B solution videos as well for complete practice. If you enjoyed learning with me, don't forget to like the video, share it with your friends and subscribe to Learn Smart with Sweta for more simple and easy to understand physics lessons. See you in the next video. Happy learning!